Hey 8th graders, this is lesson 12, session 2, which starts on page 275. Just to very quickly review session 1, go all the way back to that. Session 1 was all about what it means when you graph two lines and they intersect. What that means, that's a solution for both of those equations. Today, what we're doing differently is we are discovering what it means when you graph two lines and they do not intersect, ever, because they're parallel. Or they intersect the whole time because they're the same line and they overlap. So, let's look at this here. Number one is just reviewing again last week. It says, you have seen that a solution to a system of equations is represented on its graph at its point of intersection. It says, wherever they meet, wherever they overlap, that's the answer to both equations. Now, A says, let's try something different. Let's graph this line and this line. Okay, so this first line here, the y-intercept is 2. So there's my 2. And the slope, there's nothing there, so that means it's 1 because this is 1x. So I'm going to rise by 1 and run by 1. Rise over run is both going to be 1. And I want to connect those lines carefully. You should use a straight edge when doing these so that you're sure. See, I'm a little bit off. You want to be sure that you're really accurate when you're graphing systems of linear equations. In fact, I'm going to be so accurate that I'm going to remember to put my arrows there to indicate this line goes on forever. Okay, next one. The y-intercept is -1. And it has the same slope. 1 over 1. 1 over 1. You can even sneak that in there if you want. So up 1 and over 1. And there's my next dot. And I will connect them with a big old... Nope, way off. I gotta get it accurate. There we go. Okay. So you see these lines, not only on the graph will they not touch, but see how they have the same slope, so they will never, ever touch ever. There will always be this lonely gap between them, off forever. They will never touch. They are, put a reminder word for yourself if this word is not burned into your vocabulary. They are parallel. There we go. Those are parallel lines. So does the system have a solution? Well, they don't intersect anywhere, and we learned in session 1 that the solution for both equations is where the lines intersect. If these never intersect, then no, there is no solution. They will never intersect. Ever. Ever. Okay, we've got two more parallel lines here for Charlotte and Paloma. Charlotte and Paloma both walk the same trail at the same time. Charlotte started walking first. The graph shows each girl's distance along the trail for the first 40 minutes of Paloma's hike. So by the time Paloma had started, Charlotte was already 500 meters down the trail. Does Charlotte catch up, or does Paloma catch up to Charlotte? Is she ever going to catch up to her? If they're both going at the same rate, see how they're both going the exact same rate? We have the same slope. Same rate, also known as the same slope. So no, she's only walking as fast as Charlotte. She's gonna have to catch up. She's gonna have to speed up if she wants to catch up to her, isn't she? B, look at the system of equations. How can you tell by looking at the equations that the system has no solution, aka they're parallel lines? Well, what's the same here? What is the same? The y-intercept is not the same. The y-intercept for Charlotte is 500. The y-intercept for Paloma is nothing, 0. It goes right through the origin right there. So the thing that's the same is the slope. So how can we tell? Slope is the same. The slope is the same in both of those equations. So they're going to be parallel. They go at the same rate. Now check this one out. Different solution, or different thing. And you might have noticed infinitely many solutions. Pro tip, it's already given you kind of the answer in the title. Okay, so now we've got the graph of the equation right here. That's already on there. And now it says to also graph the equation right here and the same coordinate plane to represent a system of equations, more than one equation. Okay, so we've got our y-intercept is, oops, I want to use pink. Our y-intercept is +1. Oop. And our slope is 2. So I'm going to rise by 2. And my run is 1 because 2 is the same thing as 2 over 1, you know. So there's that. Oh, look at what's going to happen there. You can probably already see it. Ta-da! It's the same line. They right overlap. So at what point do the two lines intersect? Go ahead and put your answer. I bet you can beat me to it. All of them. You are correct. I know you already put it. Okay, so how many ordered pairs are going to be the solution? If all of the points intersect, then any point will do. And how do we explain that? Let's think of how we can word that. They intersect at, oops, I skipped a word, at all points. I skipped a letter. Points, there we go. Okie dokie. And they just snuck in 2 little practice problems here for us. Look at problems 1 through 3. In each system of equations, both lines have the same slope. Can 2 lines of the same slope ever intersect at exactly 1 point? Well, I think we already went over that, didn't we? But we should word it again to make sure we have it. No. If they have the same slope, and I should add a caveat here, if they have the same slope but different y-intercepts. They are parallel. Because you have to specify that they do have to specify that they have different y-intercepts, because obviously these two also have the same slope if it's the same line, but they have the same y-intercept as well, so that's all the same. Number 5, last one. What values of m and b will result in a system with no solution? So we've got our first equation here. And for our second one, it wants us to plug in something for the slope and something for the y-intercept that will make them parallel. And we want no solution, not infinite solutions. Infinite solutions, that's the exact same line. So that would be, we'd put in a 4 and a 5. And that's the same line, so those would be infinite solutions. We want to put in the same slope, so y equals 4x, but a different y-intercept. And you can put anything. I'm going to put 1 because it's a small number and it's easy. Yay. There we go. So, and to answer their question more properly, we'd put m, you could put 4, y, anything but 5. The slope has to be the same, but the y-intercept has to be different for there to be no solutions. There we go. Okie dokie. Practice that on your green pages, and good luck.